Okay, kids, welcome back to another math lesson from home in online land. Hope you guys are doing good. Hope you're able to get these videos and understand what we're doing. We're at the final stage of Unit 5, and that is figuring out composite figures. With composite figures, we can find the surface area or we can find the volume. You've actually done both before in warm-ups before we were shut down. You can surface area, if I took, let's say, this is one of my standard ones. If I stuck a pyramid on top of a prism, now, if I was asking you to find the volume of this figure, it's really easy. Find the volume of the pyramid and add it to the volume of the prism. It's just two problems in one. There's no complication at all. That's like if I gave you in 2 dimensions a triangle on top of a square and said, hey, give me the area. You just find the area of each. If I asked you for the surface area, though, as we did before, I explained that the top of the prism and the bottom of the pyramid are actually no longer on the outside of the figure. They're on the inside. So if I was asking you to find the perimeter of this shape, you just go around the outside of it. You would never cross this inside line because that's on the inside. You'd only go on the outside. That's the perimeter. It'd be like if you did the perimeter of the school blocks, you would walk around Lowell and Rogers. You wouldn't include cutting across. So let's do a couple of those and we'll practice, and then I'll give you a little homework assignment. It's not very complex, but here we go. All right, so let's do the easy one first. Let's find volume. Volume is no different than finding the volume of single shapes. Slow. I'll give you a height of the pyramid. Because we've been working with square-based pyramids, I'm going to give you a square-based rectangular prism. So if I put 11 inches here and 8 inches here, that'll take care of the entire prism on the bottom. You just need a height for the top. That looks like a good 9 inches. Okay. So what I want you to do is I want you to pause it and find the volume of the pyramid on top, find the volume of the prism on bottom, add them up, and let's see what we get. You ready? Okay, so the volume of a pyramid, if you watch my wonderful blunder in the pyramids video, is 1/3 the base squared, so the base times the base, so that'd be 11 times 11, base times the length, it's the same, the top and the bottom, times the height, which is 9. So 11 times 11 is 121, 1/3 of 9 is 3, 3 times 121 is going to be 363 for the pyramid. Now the prism on the bottom is going to be 8 times 11 times 11. I know that 11 times 11 is 121. 121 times 8 is 800 plus 160, so 968. So if I add 968 together, I'll do the conventional way. There's 11, there's 13, and there's another 13. Wow, that's kind of a cool number, 1,331 inches cubed. We can also find the volume of cylindrical objects or circular objects. Let's make the bottom of a cone nice and round, and let's stick this guy on top of a cylinder. Okay. There's our, not my best cylinder ever. So you need a height, you're gonna need a radius or a diameter. I'll give you a radius for this one. Sounds like a lot more fun. Let's do 6 meters. This guy looks like, let's do something easy like 10 and make this guy a height of 12. And that will be all of our dimensions needed. Okay, so we're finding volume still. So the volume of a cone is the same as the formula as the volume of a pyramid. It's the 1/3 the base area, which is the area of the circle, times the height. Or as I like to say, 1/3 of the pies are squared homes. 1/3 of the pies are square homes. Okay. And so I'm going to do 1/3 times pi times the radius, which is 6, squared times 12. 6 squared is 36. I'm going to take 1/3 of 12 and make that 4. 4 times 36 is 120 plus 24, which is 144 times pi. If I do 144 times pi, I'm going to have to break out my lovely calculator here because that's more than my brain wants to do. 144 times 3.14 is about 452.16. And that is meters cubed. But that is only our wonderful cone. Now, the cylinder is the same formula without the third, because a cone is 1/3 of the cylinder. All this one is different height. If I made this 12, it would literally be 1/3 of it. So it's going to be pies are square homes. So r squared is going to be 6 squared again. It's times 10. So I've got 36 times 10. That is 360 pi. I could have done 144 plus 360 and got 504 pi. And then I know my total was going to be somewhere over 1,500. But I'm doing this the long way. Or I don't know if this is the long way. That's an interesting question. 360 times, oops, I did it twice. 3.14 equals 1,130.4, and if I add that to this 452.16, I'm going to get 6,52851. So 1,582.56 meters cubed. That was a lot of fun. Let's see, what's another fun thing we can do? Oh, here's a fun one. You'll love this, I'm sure. Okay, we're going to do a cylinder. Missing a cylinder. What? What is this craziness you speak of? So here's my big cylinder. Okay. Now I am going to give you the radius of the little guy. He's 1. He is 1. And let's make this, so it's inside. See, he's missing. We're missing a piece. It's a hollowed out cylinder, and let's give this a radius of 3. So here's a tricky thing here. So we're gonna have to find the volume of the entire thing. Let's give us a nice, I like 10, it's just such an easy number. If this from here to here is 3 and the radius of the little guy is 1, the true radius of the big cylinder is 4. So it's going to be pi times the radius of 4 squared times the height of 10. And now we're going to be taking away a radius of 1 squared times 10. So this is going to be 16 times 10, so 160 pi. Now this is kind of fun, watch this. This is 1 times 10. What? Is this possible? It's just going to be 10 pi. we're going to subtract those and get 150 pi. Now 150 pi is going to be around a little over 450. So 150 times 3.14 is, well, whoa, 150 times 3.14, 471. There we go. Something I did was wrong there the first time. And that's going to be, oh, I didn't give units to measure. Units cubed. So, you already know how to find the volume pretty well. So let's do some practice problems with just volume. On the homework. Nah, let's not. That's not what I wanted to do. Let's do some surface areas, which we can only really do cylinders and then the prisms and pyramids. Okay, so surface area. The slightly more challenging of the two, because it's just more work. Let's start out with our friendly little pyramid on top of a prism. Okay. Now this one, let's give it a 10-meter base. So that's going to be 10 by 10 square base. Let's do 6 meters high, and we need a outside of the triangle height. Let's give that as 8 meters. These are all the dimensions you're going to need. There is a square base of the pyramid that's no longer included, and the top of the prism are no longer included. So we're finding 4 triangles on the outside, 4 identical rectangles, and then 1 square on the bottom. So try and work that out, and pause the video, and then we'll come back and do that. Okay, you've paused the video, and hopefully you've got the same answer I'm about to get. So I've got 4 triangles. Now a triangle formula is 1/2 its base, which is 10, times its height, which is 8. Now of course I could have just done 4 identical triangles make 2 rectangles, because 4 times 1/2 is 2. I've got 2 times 10 is 20, and 20 times 8 is 160. Those are my 4 triangles. Now I have 4 identical rectangles, right? They're 6 by 10, so there's 4 of them, and they're 6 by 10. So that's 24 times 10, there's 240. And then I have 1 square at the bottom, and he's a 10 by 10, 10 by 10, so he equals 100. If I add 160 to 240, well, 240 plus 60 is 300. There's 400. There's 500. So the surface area of this composite shape is 500 meters, and it's squared because it's surface area. All right. Let's do another fun one. This will be the triangular prism on top of a rectangular prism. Kind of looks like a barn. And down we go. Okay. Looks like a pretty nice little barn. All right, let's give you some dimensions. Let's do some bigger numbers here. 10 feet for the height. It's more like a real barn, although 12 feet is not. It'd be much wider than that. 18 feet is its length or depth. And you're going to need the height. Let's make that a lovely, I like 8. 8 is such a nice number. 8 feet tall roof there. So if we're finding the surface area, you have the, oh wait, you need the slant length too. Let's give you one more dimension. Let's make that 9 feet. And I'll make it over here as 9 feet as well, because I kind of need to tell you what it is. All right, so we have 4 visible sides on this top part. We have the 2 slanted sides of the roof and the front and the back of it. So I've got 2 identical triangles, and then I have 2 rectangles. Then I have a front and a back, a right and a left, and then the bottom. So pause the video and try and work it out. You should have a total, there's 4 sides on top and 5 on the bottom, so 9 different sides taken care of, and then I'll figure that out with you here in a second. Ready? Here we go. All right, I'm gonna do the front and the back triangles. There's 2 of them, and so they're canceling out that half, so it's basically the base, which is 12, times the height of 8. So that equals 96. So those are my 2 triangles, right? Now I've got these 2 rectangles, which are the sides. There's 2 of them, and they're going to be 9 by their length, which is 18. So 9 times 18. Ew. 9 times 18 is 90 plus 72. That's 162. 162 times 2 is 130. That's not fun. Brain started to not work there. So 9 times 18, basically. No, let's do 18 times 18. Right? There's 18 times 18. That's 18 squared. I should know this one. It is 324. Okay. Now we have the front and the back of the bottom. There are 2 of those, front and back. And they're 10 by 12. So that's 20 times 12. That's 240. That's a bad equal sign. Then I've got a 10 by 18. There's 2 of those. That's the right and left sides. So 10 by 18. That's 20 times 18. That's 360. And then we have the one bottom. That's 12 by 18. And 12 by 18 makes me want to use a calculator because I know 12 by 18 is 216. Ooh, that makes sense because which is also 6 times 6 times 6. Anyways, 216. We add this all up. There's 10, there's 16. Carry the 1, there's 10. Okay, so we got cut off there for a second, and so you didn't get to see me do my final adding. 1,236 feet squared is the surface area of this. And you also missed me do one more problem, which I'm going to replicate here on this other piece of paper. If you need that, pause the video. All right, here we go. What I'm going to do is I'm going to put a cylinder on top of a rectangular prism. All right, so here's the back. Come at an angle. Come by, that looks good. Now let's make it stand up. Okay. Let's give this a radius of, let's say, 2 meters. We're going to make this 5 meters tall. Let's make this guy 4 meters. Let's make this guy 12 meters and this guy 8. Okay. So the thing that's cool about, I don't know if cool is the right word for it, but when you put a cylinder on top of a rectangular prism, it covers up a portion of the top, but the top of the cylinder is the same as what's covered. So in actuality, you're not having any side of the rectangular prism actually blocked because the piece that is covered is right here. So we just find this top like normal, and we're going to ignore the circle. What we have to do is find the rectangular wraparound that goes around the cylinder. So we've got 6 rectangles we need to find for the prism. 12 times 8 would get you the bottom and the top. And that's 12 times 8 is 96, so that's getting you one side. Then if I did 8 times 4, 8 is this times 4, that's going to get me the right side. And so that's 32. And this front face is 4 times 12. And that's 48. If I add these all up, I get 16 and 17. So 176, that's 3 sides. Double that to get to your other ones. That's 200 plus 140. That's 340 plus 12, 352. And that gets me the surface area of all 6 sides of the prism. Now, the cylinder, you may remember our surface area formula is 2 pi's r square plus 2 pi's r hot. Well, the pi r squared is the top, and it's 2 because of the top and the bottom. So we're not going to do this. We're just going to do the 2 pi's r hot. So we've got 2 times pi. The radius is 2, and the height is 5. So I get, oops, I just wrote 10 there instead of 5. Can you see that 5? That's horrible. 2 times 5 is 10, times 2 is 20, so I get 20 times pi. And I know that 2 times 3.14 is going to be 6.28, so it's going to be 2.8. So if I add these two together, I'm going to get 410 plus 4 plus 8. That is the surface area of this shape. Now, I'm going to show you the 2 homework pages I want you to do. Print them out or draw them out, whatever you want to do, and then take pictures of them, send them to me, and I'll give you some type of credit for it. Here we go. Here's the first one. You'll be able to download this as well off the homework assignment. You can pause it if you want to copy it. And here is page 2. Okay, can you see all the dimensions? There we go. There's page 2. So volume for the first page, surface area for this page. Hope this lesson made sense, and I'll talk to you guys next time. Take care.